Hello, everybody. This video is about logarithms. So this is section 6.4, logarithms and logarithmic functions. We decided the definition of logarithms because it's the inverse of exponentials, that it might be best for us to say, take the exponential function y equals b to the x and create its inverse, or take the x and replace it with the y. When you do that, you invert the word logarithm. So we started with 2 to the third equals 8. We converted it to logarithmic notation or logarithmic function or equation by saying log base 2, you take the number that was in the front, make that the base, the number to equal 2 times by that, equals the exponent, which is 3. How does that apply? It applies to everything. 7 to the second equals to 49 is an easy example, but log 7 times 49 equals 2. Same thing here. The example says, write an exponential equation equivalent to log base 3, 243 equals 5. That becomes 3 to the 5th equals 243. And if you don't believe it, you can check it out in your calculator. 3 to the 5th should equal 243. Now, if you wrote the numbers wrong, say you did 5 to the 3rd, you will get a different incorrect answer. And just to double check, you double check it again. You actually have the function. Some people have these functions in their calculators. You're going to say log base 3 243, and it should equal 5, and it does. It applies. I even asked a question to some people in class, and they said 4 to the second power is 16. Log 4, 16 should equal 2. Then we moved on, and we said, hey, we've done it both ways. We went logarithm that way, logarithm to exponential, exponential logarithm. Now, log base 4 times 6 4 is the problem. This was the example that you get on your homework. So when you get your homework, it says it right here. It says evaluate each expression. Evaluate each expression. If you're going to evaluate an expression, there's no equal sign. There's no conversion. The first example, logarithm, write in exponential form. Easy. Second type of problem, exponential, write in logarithmic form. Easy. We've already converted those. This one has no explanation. It just says evaluate each expression. So what they really want you to do on an example like that is they want you to say equals b equals x. Write in a variable. So if you write that in, now you can rewrite it as the base raised to the equal is 64. That's right. If you remember, this is now exactly like a problem from the last two tests. The last two tests we've been doing solving. So when you do 4 to the b equals 64, don't think of it as 64, think of it as 4 to the third. And when you're solving exponentials, you can cross out the same base, and you get b equals 3. The answer is log base 4, 64 equals 3. Over here, it says log base 2, 64. You have to write this in. You have to write this in over here. No one else is going to do it for you. You have to come up with this part where it says equal to something. They're going to give you log 2, 64, say evaluate the expression, set it equal to x. The x equals 64. Again, 64 can be written with a base of 2, 2 to the 6th. So once you get 2 to the 6th, do we have the same bases? Yes, we can solve it, which means some of these will not be solvable if they don't have the same base.